Okay, so this to me is kind of a confusing topic, this work done by the force of gravity. But in practice, it's not as confusing as they like to make it. So just kind of keep it really simple, all right? So we want to think about, in the first case, a ball that is being thrown up. So it has some initial velocity, and then it comes to rest at the top, right? So a ball moving upward. So I would say the displacement of it's going to be up. Okay, but the gravity force is down. All right. So if I think about just the ball as the system, right? So I'm taking the earth sort of out of it, right? Instead of thinking of the earth and the ball together as having this gravitational potential interaction energy, I'm just thinking of the gravity as being like an outside force to the ball. Okay. If I think of it that way, then the ball would have some kinetic energy as it's thrown upward. Okay. And then by the time it gets to the top, it doesn't have any anymore, right? It's no longer moving. So I would say that the work done by gravity was negative. I've taken that kinetic energy out of the system. All right. Which makes sense because it slows down. All right. So then that kinetic energy that I had minus the work would leave me with nothing. All right. Notice it's not different, right? If I would have decided to put the earth in the system, I would have just had UG and then I wouldn't have had this. Okay, it's the same exact thing. It's just a different way to look at it, right? And then I would have put the earth into the system. Then that's how it would have changed, okay? But if we're talking about work done by the gravity force, which sometimes they like to say, then the earth would not go in your system, okay? All right, so similarly, in the other direction, all right, I don't want to use blue. Okay, if I start the ball at the top, right, it has no energy when I start, and it's going to fall, so its displacement is going to be downward. In this case, the gravity force is also downward, right? So since those are the same direction, I'm going to get a positive work, which means I'm going to add energy to the system through working, and I'm going to get out kinetic energy. Okay, so again, now here I'll see that the work in equals the final kinetic energy. Okay, just like if I had decided to just put UG, right, and put the earth in the system, then the UG would have equaled the KF. But it's exactly the same thing, right? Because see, that's still force times distance, which is mgh. And this is mgh. It's exactly the same thing. Okay, so it just depends on how you want to look at it. All right, but just sometimes they throw out a whacked out question like that. Okay, if I'm thinking about something on an incline, it's kind of the same thing. But again, I only can count the part that is parallel. I can only count the parallel part. So if my gravity force is acting downward, okay, I have to only count the up and down distance, right? Because anything on the diagonal isn't going to matter. I have to just have that downward component. And that's why we end up just doing the H, right? You did this in the WebAssign, I think, that D sine theta. Right, so that's going to be a positive work done by gravity as it moves down the hill because I'm adding kinetic energy into the system, okay? But I only can use the H because I need just that component that matches the direction of the gravity, okay? All right, then you can try that one.